Hi everyone. First, I would like to introduce myself. I'm Manuel Luis O. Gomez, but you can call me Master Manuel. Okay, our lesson for today is about computer basics. And these are the topics we will learn. First, we have introduction and overview of a computer, types of computers, history and generations of computer application and usages, advantages and disadvantages of a computer, and the memory unit. What is a computer? A computer is an electronic device operating under the control of instructions stored in its own memory that can accept data, okay, process the data according to the specified rules, produce information, and store the information for future use. So the computer accepts data using the input devices, okay, such as the mouse, the keyboard, the mic, and many more. Then processes the data using the processing devices, such as the CPU or the processor. Then after that, it creates an output using the output devices, such as the monitor, the speakers, projectors, and many more, okay, and stores all the information in the storage devices such as the RAM or the hard disk drive. This one is the overall function of a computer. Any digital computer carries out five functions in gross terms. Number one, takes data as input. Number two, stores the data or information in its memory and use them when required. Number three, processes the data and converts into useful information. Number four, generates output. And number five, controls all the above four steps. First, okay, it takes data as an input using the input devices, such as the mouse, the keyboard, as what I explained a while ago. Okay, and then stores the information in its memory. Okay, and then use them when required. And after that, processes all the data and converts into useful information, and then generates or creates an output using the output devices. Next, we have the two main components of the computer. Any kind of computer consists of a hardware and a software. For the software, we have two types of software. We have the system software and we have the application software. For the system software, this one is the one responsible for the overall function of the computer, such as when your computer boots, the settings, the system utilities, and many more. For the application software, these are the programs that you use for your own purposes. Next, we have the hardware. Okay, all the parts of the computer that you can see, you can touch using your hands, such as the monitor, okay, the scanner, the printer, the mouse, the keyboard. Okay, now let's move on to the hardware. Computer hardware is the collection of physical elements that constitutes a computer system. So everything that you see in your computer, all the parts of your computer are considered as a hardware, okay? Such as the mouse, the RAM, the ROM, the CPU, the graphics card, the motherboard, the hard disk drive, all of it are considered hardware. These are different kinds of hardware devices. Number one, we have the input devices. Number two, we have the processing devices. Number three, we have storage devices. Number four, we have the output devices. For input, I give some examples here. We have the keyboard, mouse, the scanner, UPC reader, microphone, and many, many more. We have the processing devices. We have the CPU, the main memory, the RAM, okay, special function cards. For the storage devices, we have the magnetic disk, we have the optical disk, okay, we have the magnetic tape, we have the flash drive, and many, many more. For the output devices, we have the video display or the video card, the printer, the speakers, the projector, the plotter, and many more. These are examples of input devices. We have the joystick, we have the mouse, we have the keyboard, we have the scanner, and many more. These are the processing devices. We have the processor or the CPU. For the CPU or the central processing unit. CPU is the brain of the computer. It is responsible for all functions and processes. Regarding computing power, the CPU is the most important element of a computer system. There are three main parts of the CPU. You have one, ALU, or what we call the arithmetic logical unit. This one executes all arithmetic and logical operations. Arithmetic calculations like addition, subtraction, multiplication, and division. Logical operation like compare numbers, letters, or special characters. Next, we have number two, the CU or the control unit. This one controls and coordinates computer components. Okay, this one controls all the parts of your computer. Read the code. Okay, next, read the code for the next instruction to be executed. Increment the program counter so it points out to the next instruction. Read whatever data the instruction requires for cells in memory. Provide the necessary data to an ALU or register. If the instruction requires an ALU or specialized hardware to complete, instruct the hardware to perform the requested operation. Third, we have the registers. Stores the data that is to be executed next. Very fast storage area. This one is what we call the von Neumann diagram. Okay, so I'll explain this. First, we have the input devices. Okay, for the computer to accept data, we need to use the input devices. All right, and then after that, it goes to the central processing unit. Okay, and then it goes down to its memory, and then it goes back to the central processing, and then it goes to the output devices. All right, so as what I have explained a while ago, the central processing unit has three parts. Okay, three main parts. We have the control unit. The control unit is the one responsible for controlling all the computer components. ALU or arithmetic logical unit is the one responsible for all the arithmetic operations or logical operations such as additions, subtractions, multiplications, etc. And register is where all the information is stored. Okay, here we have storage devices. So these are examples of storage devices. We have flash drives or thumb drives, we have floppy disk, we have CD, we have DVD, we have smart media, we have hard disk, removable hard drive, micro drive, memory stick, and many more. Now let's move on to storage devices. We have two types of storage devices. We have the primary memory and we have the secondary memory. Now let's talk about the primary memory. Okay, we have the RAM and ROM. First, let's talk about RAM, or what we call the random access memory. This is a memory scheme within the computer system responsible for storing data on a temporary basis, so it can be promptly accessed by the processor as and when needed. Okay, so all the data and information in the RAM is just temporary. So for example, you open up a program, okay, data and information goes into the RAM. After you closes the program, all the information or data be deleted. Okay? Same as when you play a game. Sometimes games consumes a lot of RAM. So when you play quality games, it uses a lot of RAM. After you close the game, all the data, all the information will be okay, so then your RAM will be cleared. Next, we have the ROM or read-only memory. ROM is a permanent form of storage, stays active regardless of whether the power supply to it is turned on or off. Okay, so whether your computer is on or off, the data stays in the ROM. Okay, it doesn't allow data stored on them to be modified. Okay, so it will never be modified. Okay, what kind of data and information stored in the ROM? Your booting settings, okay, on how your computer boots, okay, on how your computer drivers work, okay, on how the peripherals or the parts of your computer function. Okay, all of those information or data are stored in the ROM. So this is how a RAM and a ROM looks like. First we have the RAM, second we have the ROM. Next, let's go to the secondary memory. Stores data and programs permanently. It's retained after the power is turned off. So all the data and information stored in the secondary memory will never be removed unless you remove it yourself. Okay, examples, we have the hard disk drive or the HDD. Second, we have the optical disk, okay, or the ODD. Next, we have the flash disk or what we call the flash drive, okay? So these are examples of secondary memories. So this is how secondary memory looks like. You have the HDD, you have the ODD, and we have the flash drive. For the output devices, okay, these are examples. We have headset, we have printer, we have projector, we have speakers, we have monitors, and many more. Okay, now let's move on to types of computer. Computers can be broadly classified by their speed and computing power. Okay, so these are examples of computers. Number one, we have a PC or a personal computer. It is a single user computer system having moderately powerful microprocessor. This is what we use at home. Okay, a personal computer. Next, we have a workstation. It is also a single user computer system, similar to personal computer, however, has a more powerful microprocessor. Workstation you can see in offices, okay, in banks, in schools. Mini computer. It is a multi-user computer system capable of supporting hundreds of users simultaneously. Okay, so it is capable of supporting hundreds of users simultaneously. Next, we have a mainframe. It is a multi-user computer system capable of supporting hundreds of users simultaneously. Software technology is different from mini computer. Okay, so it's a bit different from mini computer. Next, we have the supercomputer. It is an extremely fast computer which can execute hundreds of millions of instructions for seconds. So a supercomputer is really fast. It can execute hundreds of millions of instructions per second. This is how a personal computer look like. Okay, just like your computer at home. Next, we have a workstation. Okay, this is what you see in a company, in an office. Okay. Next, we have a mini computer. It looks like this. Okay, it looks like really small. Okay, it can support up to 250 users. Next, we have the mainframe computer. Look at this. Okay, these computers are used in big companies. Okay, capable of supporting hundreds or even thousands of users. And next, we have the supercomputer. Okay, supercomputers are one of the fastest computers currently available. Okay, so if you see big organizations like mining, data mining, or Bitcoin mining, maybe they use these kinds of computers. Film company, where they render big files, big kinds of quality images. Okay, they use these kinds of computers. Okay. Okay, now let's move on to the history of computers. Earliest computer. Originally, calculations were computed by humans whose job title was computers. Okay, long time ago, the first computer was actually a human. Okay, these human computers were typically engaged in the calculation of mathematical expressions. The calculations of this period were specialized and expensive, requiring years of training in mathematics. Okay, so they don't just get people to be a computer, okay, to calculate mathematical expressions. Okay, they do trainings, okay, long years of training in mathematics before they get hired to be a computer. The first use of the word computer was recorded in 1613, referring to a person who carried out calculations or computations, and the word continued to be used in the sense until the middle of the 20th century. Okay, the ENIAC computer. ENIAC stands for Electronic Numerical Integrator and Computer. It was the first electronic general purpose computer completed or created in 1946. Okay, the founder were John Presper Eckert and John W. Mock. Okay, so this is the first electronic numerical integrator computer. Okay, we call it the ENIAC, ENIAC. Next, we have the ABC or the Atanasoff Berry computer was first automatic electronic digital computer, an early electronic digital computing device that has remained somewhat obscure. The ABC priority is debated among historians of computer technology because it was neither programmable nor Turing complete. Okay, so before this ABC computer were not actually programmable or Turing complete. Okay. Okay, computer generations. There are 5 generations of computer. The first generation was in 1946 to 1958. Second generation was 1959 to 1964. Third generation was 1965 until 1970. Fourth generation was 1971 until today. And the fifth generation onward is today, up to the future. The first generation, 1946, 1958. The first computers used vacuum tubes, okay? This is how a vacuum tube looks like, okay? For the circuitry. and magnetic drums for memory, and were often enormous, taking up entire rooms. Okay, so they were using a lot, okay, large number of vacuum tubes and magnetic drums for the electric circuit of the computer and for the memory to store data in it. And it was very expensive to operate. And in addition to using a great deal of electricity, okay, it uses a lot of electricity, okay, a lot of heat, which was often the cause of malfunctions. Next, we have the second generation, okay, it already uses transistor, okay, so it was in 1959 to 1964. Okay, transistor replaced the vacuum tubes, okay, so they upgraded, okay, they don't use the vacuum tubes anymore, and now they use the transistor, okay, it looks like this one. Okay, so one transistor replaced the equivalent of 40 vacuum tubes. Okay, one of this is equivalent to 40 pieces of vacuum tubes. Okay, so it requires smaller space. Okay, to create the computer using a transistor. Okay, allowing the computers to become smaller, faster, cheaper, more energy efficient, and more reliable. Okay, but it's still generating a great deal of heat. Okay, it can also damage the computer. Then after that, we have the third generation during 1965 to 1970. Okay, now they already developed the integrated circuit. Okay, so when I was young, we used to use this one, integrated circuit. Okay, transistor were miniaturized. Okay, they make the transistor very small. Okay, and placed on silicon chips called the semiconductors, which drastically increase the speed and efficiency of the computers. Okay, much smaller, cheaper. Okay, compared to the second generation. Next, we have the fourth gen. Okay, so this is what we use now. Okay, the microprocessor. So look at your computer. Okay, we already using the microprocessor. Okay, the microprocessor brought the fourth generation of computers as thousands of integrated circuits were built onto a single silicon chip. Okay, as these small computers became more powerful, they could be linked together to form networks, which eventually led to the development of the internet. And the fifth generation onwards is today, up to the future. Okay, based on artificial intelligence or AI. Okay, now it's still in development. Okay, the use of parallel processing and superconductor is helping make artificial intelligence a reality. Now we already have robotics, right? So when you were in M1, you were using robots. Okay, when you were in M2, you were using robots as well. The goal is to develop devices that respond to natural language input and are capable of learning and self-organization. There are some applications such as voice recognition that are being used today. A lot more. So we also have the biometric technology, right? We have fingerprint scanners, we have iris scanners, hand, face, and a lot more. Now let's move on to computer applications and usages. Okay, so where do we use the computer? Okay, so in businesses we also use computers, okay? For the payroll calculations, budgeting, sales analysis, financial forecasting, and many more. Okay, I will not explain all of this anymore. Okay, you can read it later on. Of course, also in banking, in banks, you can see a lot of computers there used to uh, do the accounting. Okay, in ATM machines, those are computers. Okay, which are completely automated. In insurance companies, okay, they also use computers, of course. Okay, to keep all the records up to date. Next, of course, we have education at school. Right now, you are in front of a computer. We are using a computer to study. Okay, the computer provides a tool in the education system known as the CBE, computer-based education. Okay, it involves control, delivery, and evaluation of learning. Next, we have, of course, marketing. Okay, advertising, home shopping, online shopping, shops. Okay, a lot. Okay. Next, we also have healthcare. Okay, in hospitals, you see computers also as well for the diagnostic system, for the lab diagnostic system, patient monitoring system, pharma for the medicines, the surgeries, and many more. For engineering design, of course, for structural engineer, okay, they use a computer to design. Okay, for industrial, for architectural, okay, you know this. Okay, some of them use 2D programs, 3D programs to build the drawings. Next, we also have the military, of course, like for these examples, missile control, military communication, military operation and planning, smart weapons. Okay, so our military here in Thailand also uses a lot of computers, okay, to control everything. Communication, of course. Nowadays we use computers to communicate, not only phones. Okay, we create emails using computer, we chat, you use internet, okay, FTP, telnet, video conferencing, all of those. Government, of course, okay, to handle the budgets, the sales tax, okay, the income tax, computation of male and female, okay, the population, computerization of voters, okay, PAN card, weather forecasting, and many more. Next, we have the advantages and disadvantages of a computer. Number one, high speed. Okay, computers are very fast device, okay, capable of performing calculations easily, okay, a very large amount of data. Accuracy. Okay, computers are very accurate. Calculations are 100% error-free. 3. Storage capability. Okay, memory is a very important characteristic of computer. Okay, it can store more data, okay, than human beings. Diligence. Okay, unlike human beings, a computer is free of monotony, tiredness, and lack of concentration. As a computer doesn't get tired, it can work continuously. 5. Versatility. Okay, it is a very versatile machine, very flexible in performing the job. Okay, it can use to solve the problems related to various fields. Reliability. A computer is a reliable machine. Okay, easy to maintain. Okay, easy to do the maintenance. 7. Automation. Okay, it's all automatic. Okay, ability to perform a task automatically. 8. Reduction in paperwork and cost. Okay, so we don't use too much paperwork. Okay, papers to do the work. Okay, the computer does it for us. Disadvantages. No IQ. It is just programmed by a human. Okay, it operates using a program for a human to understand. Dependency. It will not work until you use it. Environment. Environment should be dust-free. Okay, suitable or cool. No feeling, of course, or emotions. Okay, now let's move on to memory unit. Let's start from the smallest memory unit up to the biggest memory unit. First, we have the bit, bit. This one is the smallest unit of computing. Next, we have the nibble. Nibble is composed of 4 bits, is equivalent to 4 bits. Next, we have the byte, okay, is equivalent to 8 bits, or a single letter on the keyboard. For example, A. A is equivalent to 8 bits. Okay, the computer understands it as 8 bits. Next, we have the kilobyte, composed of 1024 bytes, or a single picture. Next, we have a megabyte, equivalent to 1024 kilobytes, or an MP3 song. Next, we have a gigabyte, equivalent to 1024 megabytes, or a single movie. Next, we have a terabyte, is equivalent to 1024 gigabytes. Data consists of bits and bytes. A bit is the smallest unit of data. The word bit comes from binary digit, okay? BI from binary and T from digit, okay, the last letter. A bit is represented by a 0 or 1. The 1 actually represents a small flow of current, and the 0 represents the absence of current. It means to say 1, the current is on, and 0, it means the current is off. Okay, so on, off, okay? A byte is 8 bits stuck together in a chunk, one after the other. Example, 01110001 is an example of a byte. 0, it means to say the circuit is off. 1, it is on. 1, it is on. 1 is on. 0, off, off, and on. So it's simply like this. Off, on, off, on. Okay, so that is a single byte. Okay, it represents something. It can be a letter, let's say. Numbers that consist of just zeros and ones are called binary numbers. Okay, I'll give you some examples. This is an example of binary numbers, okay? You often see this in movies, right? Lots of ones and zeros on the screen. So this is an example of a data, okay? On how a computer compute, how the computer understands all the information. They use 0 and 1. So here are examples of characters or letters and their equivalent in binary code. So here we have A, equivalent to 1 byte, which is composed of 8 bits or 8 binary numbers, 0, 1, 0, 0, 0, 0, 0, 1. Okay, so off, on, on. Okay, you can see all the conversions here in binary code.